All right, do you see the slides?
Yeah.
Yep.
Okay, so let us begin. Colin, will you start talking about the Solar System Science Collaboration?
Yeah, sure. So firstly, apologies from Meg and David that they are not here. But as Fred was saying, it's the DPS conference this week, which is the big annual meeting in the States for planetary science. And if you go on to the next slide, they have an even better excuse for why they're not here right now, because at the moment they're running LSST in the Solar System Workshop, which is going on as we speak at DPS. So this is to kind of tell the rest of the community about what's going on with Solar System Science Collaboration, with LSST in general. The next slide says what we've been up to. So last year, the main thing was getting this science roadmap finalized and agreed, and you can read this because it was on archive. So this was all done in February. And then the next slide says, well, what we're up to now and the focus for the current year, which is to try and get the solar system software roadmap. So how do we achieve the stuff in the science roadmap? That's being drafted at the moment. Expected by end of the year there should be a plan for what we want to do with that. What tools and pipelines and things do we need to achieve the science roadmap, basically. And then next, so the other thing that's ongoing at the moment is talking about publication policy. So there's a few of us being opted into a small committee that's discussed this, and then I believe Meg was writing up the conclusions from these discussions on the plane on the way to DPS, and this is going to be kind of sent around and approved by the rest of the collaboration very soon. The next thing is the ongoing efforts at the moment. So the main thing are working towards white papers. There are a few plans that are solar system. Firstly, looking at deep drilling fields and what we get in there for solar system. There's an effort to look at the North Ecliptic Spur, because that's kind of one of the priorities for solar system, especially the outer solar system people and the cometary activity people, is not introducing biases by missing one direction in the ecliptic. And then there's a third white paper planned looking at what we'd want to do in twilights potentially for solar system. There's a couple of other things people are still thinking about, but those are the sort of three that are definitely happening for now. The next slide is reporting on, we had this readiness sprint in the summer in Seattle. So there were 24 people from Solar System Science Collaboration attended this. The idea was to sort of learn about what LSST will do and the data products will be like, and how to write metrics and plan things. And so everyone was using this Jupyter Hub, which is being hosted at University of Washington, and that's now available for people within the collaboration in general to use for running simulations. So the idea is you can generate whichever sort of orbital collection of orbits you want as a population, and then run it through LSST operation simulator, and so you can test different cadence metrics and so on. And so that was developed and trained. A lot of people trained at this readiness sprint, and is now more generally available. The next slide says the other outcome from the readiness sprint was going through this data products definition document. So going through and finding what products and what values we wanted for solar system objects output from the LSST. So the outcome is to have this as proposals saying this is the data product schemes that we need, this is what the community needs, what things the community should be producing in the collaboration, and what things projects should be producing. So we now have this scheme defined, and this is an idea, that we can go into commissioning with a plan of this is the products we expect to have, and that the community can be aware of what to expect. And then I think the final slide is that there'll be a second sprint, so a second readiness sprint next summer in Chicago in June, which is about to be announced to the Solar System Science group to continue what was done this year, basically getting the consortium members up and running in readiness to use LSST data and do good science. That's all I have for now. I can try and answer questions, or better, you can send them to Meg and David, who actually know what's going on.
That's great. Thanks, Colin. 2 minutes under time.
There we go. So, tons of time for questions that I won't be able to answer.
Yes, I didn't see any questions pop up on the chats. I don't know if anyone else has anything that feel inspired to ask Colin.
I do have a question.
Yeah.
So what was the outcome of the readiness sprint in terms of, I know that some of the discussion for the solar system was whether, basically how much processing aside from the MAPS that is run by the project should happen, and whether MAPS is going to fulfill most or all of the needs for discovery of solar system objects. Is there any updates on that?
So, my understanding is that the outcome was this solar system data products table. So this thing that was shown on the previous slide, and there's a link to go and you can see this scheme. So this is kind of listing all of the parameters for solar system objects. So the sort of the matches with what the object IDs are, and the matches to Minor Planet Center catalogs, and the kind of what information we expect the project pipelines to be producing. There will be additional products beyond that will be Solar System Science Collaboration products that will be proprietary within the collaboration rather than immediately public to all. And then, so that's been some of the discussion along with the publication policy, is how we then kind of, why we need a publication policy is if people are using these things that are proprietary within the collaboration, they have to play nice in terms of how they publish results based on those. So I think examples of that will be things like sort of deeper stacks or searches for activity, sort of faint activity of round objects and so on, that are things beyond what the MOPS is expected to do.
Thank you. So I think we can go to the next science collaboration, which is the AGN Science Collaboration. Neil, I saw you online.
Hi. Yep. Okay. Do I have control of this thing, or are you controlling the slides?
I'm controlling it because I'm
Okay,
sharing
fine.
my screen. Yeah.
Okay. If we can go to
Tell me next.
Go to the next slide, please. Great. So the LSST AGN Science Collaboration currently has about 50 members. They're listed there on the right. And we are presently working as a loose confederation, where we share information to help each other, but we're not functioning as a proper hardcore collaboration in, say, a particle physics sense, just because of funding constraints as being one big issue. We certainly hope to, move toward being a proper collaboration in a hardcore way as LSST construction proceeds. Nevertheless, we have managed to accomplish a number of important things. We have prepared a roadmap document that's available on the AGN-SC webpage that prioritizes the various tasks that we will need to accomplish by the time LSST operations begin, and that can be used to prioritize funding proposals and so on. We also have had a number of workshops and small gatherings where we have talked about the science we aim to do, and we have captured all the slides from those, as well as recordings, usually just of the audio of those, and a lot of that's available on the the website as well. And so we have well-defined, exciting science goals we aim to accomplish. Some of those meetings, we had a roadmap development meeting at the AAS where a lot of science was presented. We've had smaller gatherings, one of a bunch of UK folks who are interested in AGNs and galaxies, as well as there was a gathering down in Chile. And so we're doing our best to coordinate internationally as well. And then we had a session at the recent LSST project and community workshop as well, where there were 4 or 5 AGN talks there. And again, all that stuff is on the webpage. And then we have also been working to contribute to the planning of the cadence. We contributed to the large cadence document that Phil Marshall led, and we are working on a few white papers for the upcoming call, which I will tell you about near the end. The other big thing the other key things that we've been doing are we've been clearly analyzing precursor data to LSST to get ourselves ready. Oh, no, go back to the previous slide. Okay, that includes, for example, the current deep field surveys, like the Chandra deep fields and Stripe 82 is what sort of a wider field survey that, say, Gordon Richards has been doing a lot of work on. And then people are analyzing data from PanSTARRS and DES and HyperSuPrimeCam, all with being steps toward moving to be ready for LSST. So that's been one big activity. A second big activity, which I'll give some details on in just a minute, we've been gathering key multi-wavelength data in the deep drilling fields. For example, Spitzer data and X-ray data, and that's essential just because of the very inherent multi-wavelength nature of active galactic nuclei. You need that very broad bandpass coverage to define ground truth complete samples of AGNs and to accomplish the best science. Now, all that being said, we've made some decent progress, but we all recognize there's a huge amount of work still needed, on topics as basic as just AGN selection through to analysis of LSST simulations and detailed science planning and pooling of observational resources. And again, we're doing our best on those things, with the real challenge being the lack of any sort of funding to give us a proper focus on things. So let's go ahead to the next slide. So this slide just shows the AGN-SC website, and under the various links there, you can get those. You can get that roadmap document. You can get the talk slides, the recordings. You can get our contributions to the cadence and so on. Next slide. Yes, and so this has been one thing where I think we have been able to be quite active. We have, as I mentioned, gathered excellent multi-wavelength data now in the currently defined 4 deep drilling fields. This is just showing one example where Mark Lacey led a project to get a lot of Spitzer coverage with warm Spitzer to cover the full footprints, the full LSST footprints of 3 of the 4 LSST deep drilling fields. We tried to get all 4, but they couldn't accept one of the fields for technical reasons. And those data are now on the ground and analyzed, and so we have that ready to go. So that's been one big thing. Next slide, please.
Neil, that's fantastic.
Yeah.
You got 1 minute of your 5 remaining.
Got it. I'm making good progress. Okay. Another big thing that we've been doing is we've been gathering X-ray data. We were delighted recently to win in total a 5 million second program on XMM Newton, and there we are aiming to get X-ray coverage of the XMM LSS, Chandra Deep Field South, and ISS-1 fields. In fact, we already have the XMM LSS field fully analyzed and published in a paper by Chen et al. Data for the Chandra Deep Field South region are currently incoming right now. We have about 500 kiloseconds of data in that field. In total, we'll get about 2 million seconds of data in that field. And then ISS-1 will be starting in about a year. And so we hope to have all those data on the ground, fully analyzed and cataloged by the time LSST begins operations. In total, we expect to generate in those 3 fields about 12,000 AGNs, as well as about 760 X-ray groups and clusters. And again, all these multi-wavelength data will let us define these ground truth AGN samples that will let us calibrate AGN selection with LSST data, and we can take the things that we learn from these very well-studied fields and use this to optimize AGN selection for the full main LSST survey. We ultimately hope to get something like 50 million AGNs. Next slide. This is my last one because I see you're anxious there, Phil. So finally, we have been working, I've been working very hard over the past week now on one of the white papers that we currently plan 3 white papers, 1 to be led by me, 2 to be led by Gordon Richards. Mine is focused entirely on defining the best footprints, the best cadence choices, and then the needed total depth of observations for AGN science in the 4 currently selected deep drilling fields. I already have about 15 solid pages of that written, and it's accreting at about a page per day, and so it's coming along pretty well. And we are also coordinating productively with the Dark Energy Science Collaboration folks. We had this meeting in New York City maybe a month back now, and we came up with a decent joint cadence solution that would make the Dark Energy Survey folks happy as well as the AGN folks happy. And so I am in daily communication with Dan Skolnick, to try to make sure that we're on the same track as he's writing his white paper and I'm writing our white paper. We're making sure that everything is locking together suitably. And I'll stop there because I'm probably over time. Thanks.
Thanks, Neil. All right. I didn't see any questions pop up on the chat, but anything springing to anyone's mind? Neil, has anyone been in touch with you from any of the other science collaborations about your wonderful Spitzer and XMM data?
Let's see. Well, certainly some of the Galaxies folks are interested, and some of the Galaxies, like Manda Banerjee, she is a co-investigator on the XMM project, as one example. And there are other people who are members, mainly like the Galaxies folks. But we're certainly happy if people have interest from, cluster point of view, for dark energy science or whatever. We're certainly very happy to talk with people about that.
Yeah. Cool. Yeah, I think if it's okay with you, I'll show the slide to our clusters group, see what they make of it.
Yeah, that's great. Yep.
I got a quick question.
Yes, go ahead.
Do you have some estimate of what fraction of the total LSST survey time this might take?
For the, I missed, I think you had an audio drop out there, the first part of that. Are you speaking of the 4 deep drilling fields, Tony?
Yes.
Yeah, well, okay. The AGN folks aren't actually as aggressive as the Dark Energy Science Collaboration folks. And so I believe Dan Skolnick's plan is something like about 6% of the LSST time he wants to invest in the deep drilling fields. Now, that is, to chase around their high redshift faint supernovae and such. From an AGN point of view, we don't require as much depth as the Dark Energy Science Collaboration folks want, but we'll be happy to take it if they're going to go get it for us. We can do it considerably more economically just from a pure AGN point of view. And if you're interested in that, Tony, just send me an email and I'll send you the link where you can see the current white paper.
Okay, great. Thank you.
I believe just from a pure AGN science point of view, we could probably do the 4 deep drilling fields with about 3 to 4% of LSST's time.
Thank you.
Yeah.
Yeah, thanks a lot, Neil. That was great.
Yep.
I guess we should move swiftly on. Eric, do you want to take these? Is Eric still with us? He had to start driving at some point.
Yeah, absolutely. Can you hear me?
Okay. Yeah.
There might be some background noise. If it's bad, let me know. So we're the Dark Energy Science Collaboration, and we now have a science requirements document after tremendous work. I think this has been a major effort for us over the past year, and the lead taken by Rachel Mandelbaum, our analysis coordinator, produced a very useful document. Just to highlight from it here is that we now have our own internal forecasts for how well LSST will constrain each of our dark energy probes, And then in combination with stage 3 priors, our final result in the smallest little black ellipse here, after the first year of survey data on the left and after 10 years on the right. I actually had fun yesterday and compared this to the similar figure in the LSST science book, and our constraints on W naught are about a factor of 2 better now. The supernovae have become more complementary in terms of the pivot redshift that they probe. So it's very nice to be finally improving on the very good forecasts that were made a long time ago for the science book. And then the next slide. This is now the less pretty picture side of having a science requirements document, but very important. We have high-level requirements, such as making sure that our figure of merit for constraining dark energy is something that will make the Department of Energy happy that they funded the LSST camera. And those flow all the way down with assumptions the data meets the LSST science requirements document and reasonable further assumptions through error budgeting to detailed requirements on how well our pipelines for analysis have to be able to constrain our systematics. So in this particular example, this is a flow down from that high-level requirement to systematic uncertainty in the PSF, point spread function model size, and a specific constraint of 0.1% precision on that. I guess next slide at this point. One can read through our science requirements document, and we can also draw to your attention the most interesting points. So since this is a primary audience today of project folks, we wanted to highlight something that causes a lot of exciting discussions now between desk and members of the project, which is that our Supernova probe has a more stringent desire for photometric calibration than what is promised by the project science requirements document, which is 5 millimag precision in GRIZ, and we'd actually like to get to 1 millimag. Here, this is phrased as a detailed requirement, but we have a very careful caveat that since we cannot guarantee project will produce anything better than in the project science requirements document, an alternative way to meet this requirement is for us to come up with better analysis methods anywhere else in our probe space that makes us be able to tolerate the 5 millimags. That being said, folks from project have been outstanding in being willing to talk to us about how it may be possible to achieve millimag precision on the photometric calibration. And we held a photometric calibration workshop in Paris a couple weeks ago that we'll mention again in a couple slides. Good to move on. Great, so as many of you are very busily thinking about observing strategy white papers are underway, we're writing 2 of them, the first on the wide, fast, deep, the second on deep drilling fields and mini surveys, which for us is primarily about the deep drilling fields, as Neil was implying in terms of having talked to Dan Skolnick about it. Here's just a summary of our high-level recommendations. These are pretty fixed at this point. We're going to undergo internal review on these white papers starting in just a couple of days. So it's worth looking down this and seeing where this meshes with other science collaborations goals, and if you have any questions or complaints for us about it. Perhaps most salient one for wide, fast, deep is keeping things at 18,000 square degrees, but shifting out of the galactic plane to lower extinction regions, and then allowing a redesigned galactic plane mini survey that's optimized for galactic science to fill that area, doing visit pairs in different neighboring filters, and then for the deep drilling fields, adding a 5th one to match Euclid and W first and going for longer seasons and more regular cadences. Fine to move on. Great, so this is something that's dear to a number of us, and I'm sure Phil could say more about. The plastic has an active challenge going on with over 300 participants. I think it's over 50 different teams competing in it. It is available to LSST folks to compete in this because we very carefully firewalled off the subset of desk and the transients and variable science collaboration that know the answers. And so everybody else can participate in this challenge. And what might be useful more broadly from this is that we now have an example intercollaboration agreement to support the publication of joint papers. And we can make that intercollaboration agreement to anyone who'd like to see it as a template for other intercollaboration agreements you might wish to pursue. And this allows us to have joint papers as even one submitted already. And that's led by Alex Maltz. And if we, yes. And so here's the little snippet showing you the title and author list on that. We managed to keep the author list from ballooning in any terrible way. It simply plugs the desk and TVS science collaborations at the end. Next slide. Great. So we're at our data challenge 2 stage within the Dark Energy Science Collaboration. At this point, we're trying to scale up the simulated image and DM stack processing. It's 300 square degrees. We're trying to simulate 10 years. We may only get through a few of them with our current computing allocation, but this still should be an extraordinarily useful data set. It's all 6 filters, and we're doing both a WFD simulation over those 300 square degrees and a roughly 2 square degree deep drilling field simulation. We simulate things at the chip level, so it doesn't have to be a full LSST field of view. And we already have some test sets that are processed for which we've shown the feasibility of analyzing this with the DM stack and had really valuable interactions with the data management team to help learn how things are going and to do a little bit of troubleshooting when needed. And that includes having added Leanne Guy as a new project liaison. Okay, so the final slide here is about the sprint week. Oh, I should still mention about Data Challenge 2 that we'd like to release this publicly. We know this will be of great usage to the LSST science community, including the other science collaborations. That's not imminent. We'd like to do it sometime around January of 2020, and doing so through the LSST science platform would be ideal, and is going to require some conversations with projects, so we'd be open to feedback. And then the final slide, thanks Phil, is this sprint week that's happening this week in Edinburgh. There are 50 of us there doing all sorts of sprints and hacks, and this has become an annual event for us. The picture shown is actually from a most recent collaboration meeting at Carnegie Mellon in July. These meetings have been supported very generously by LSSTC through Enabling Science, and we're wondering, as I'm sure many other collaborations are, if there's going to be another LSSTC call for proposals this winter. And we can take questions.
Thanks, Eric. I didn't see anything come up on the chat, but perhaps it's something's occurring. I wondered whether Fed had any news on the LSSTC proposal call.
I do, and I was debating whether I wanted to interject with that. So currently there is the LSSTC is looking for budget to support future enabling science calls, and we can have a discussion about it. I will punt it off to have a discussion about it online. There's no official statement. If money becomes available, the calls will become available immediately after the money becomes available. But there is some follow-up, which is monitoring programs that we could apply as a team or combining collaborations for applications. So I will follow up on that. And we're actually well past the halfway benchmark, and we only covered 3 out of 8 science collaborations. We're running a bit behind.
I know, my fault. Sorry. So, Sagata or Amanda, which one of you is this?
It's Sagata. Hi, Phil.
Hey there.
Okay, so I'll keep this short. So, as Federica said, Amanda and I have just taken over as co-chairs of the Galaxy Science Collaboration. So, this is my first meeting with you guys. Okay, so
throwing you in the deep end.
That's fine. All right. So, next slide, Phil. Okay, so first, let me mention the roadmap. So a lot of work went into producing this roadmap. We published the roadmap on archive towards the end of last year. So this essentially, as with other roadmaps, it summarizes the key science that we plan to do, both with LSST commissioning data and also with precursor data from surveys like HSC, and some of it's already in progress. Next slide. So the structure of the Galaxies collaboration, so we have about 120 members to date. So new chairs have taken over in September. So what we're focusing on right now is to streamline our working group structure so that it aligns better with the roadmap. And we essentially have sort of 5 main areas that we want to focus on in the next year or so. And so the working group structure will hopefully reflect those plans. So we have things like low surface minus science, which is going to be one of LSST's sort of niche science areas, if you like, simulations and techniques, CD fitting photosys, morphological analysis. And we have one working group which is going to look at survey strategy and hopefully contribute to white papers, perhaps also in collaboration with other science collaboration white papers that are being put out. Okay, next slide. All right, so the white papers which are sort of Galaxy specific, there are 2 which are which are in progress. So there's one by Bene Holwerda. So he's writing a white paper on what kind of Ubend characteristics we would like to have to maximize science. So essentially how would you match the Ubend with the other optical filters that LSST is going to have, especially on the deep drilling fields. And the IAC group in Tenerife, in Spain, so they're doing a lot of work on low surface brightness science using the Stripe 82. So they have their own sort of incarnation of the Stripe 82 data, their own reduction, and they are putting together a white paper on the best way to essentially build sort of degree scale PSFs. And the reason you would need these PSFs is because you want to understand galaxy outskirts, you want to understand sort of tidal features on the outskirts of galaxies, etc., etc. So you need to have very accurate PSFs which extend, way out of one effective radii, essentially. So those are the two white papers that I'm aware of, which are being written at the moment. Okay, next slide. All right, so since Amanda and I have just taken over, there's still a lot of stuff that we are sort of getting used to. So there are some activities in progress. So I think we are probably behind some of the other science collaborations in terms of firming up a publication policy, but we're hoping to. So there's a draft was produced by Brant and Mike. So Brant Robertson and Mike Cooper were the previous chairs, so we're revising that at the moment, and the hope is to finalize that sort of by early next year, and also by early next year we hope to update and adopt a charter and a code of conduct. So hopefully by early 2019 we'll have these documents in shape. Okay, next slide. I think this is the last one. All right, so I just wanted to mention LSST UK. So LSST, so for people who are not aware, the UK was bought into LSST 3 years ago now. So the UK essentially has 100 academics. Every year the UK chooses 100 academics who have LSST access. And our research council, STFC, has agreed to essentially fund our LSST effort over the lifetime of the project. So in phase A, it essentially brought us in to the LSST project by paying the subscription or promising to pay the subscription. And there's going to be three phases, so phase B, C, and D. So phase B is funding for essentially pipeline development, so for level 3 kind of stuff. So we've had a pretty brutal selection process. So there were 35 proposals put in, 9 were selected, and we put in a proposal to STFC, who then gave us a funding envelope which was half of what we bid for. Then the selection was done again, and so there are 4 or 5 work packages which we hope are going to be funded. So what does that mean? It means that we're going to have some postdoc effort, which is going to interface hopefully with the global LSST collaboration and work on producing things which are going to be useful for the collaboration as a whole. 2 of the things which are galaxy specific are low surface brightness science. So we're going to have someone hopefully who's going to work on doing accurate background modeling, background subtraction, essentially. So you preserve things like intracluster light, tidal features, galaxy outskirts, etc., etc. So without that kind of background subtraction, doing any kind of low surface brightness science will be difficult using LSST. So that's one proposal which is hopefully going to go through. And the other one is a data fusion proposal, which I think some of you are aware of already. So this is essentially how to fuse or how to combine at the pixel level LSST optical data with other data sets, for instance, WFIRST to Euclid, etc., etc. So that's an update to LSST UK, which hopefully will be playing some role in the Galaxy's work in the next few years. So I think that's all I had.
Thank you.
And questions?
Briefly, can I mention the Ubend white paper? I encourage you to get in touch with the Transcendental Variable Stars Collaboration. Suvi Ghazari was thinking of what are the Ubend requirements for tidal disruption events, so that may be a good link and a point of synergy between the two science collaborations.
Yeah, I can say also,
good.
Subi has provided some text for the AGN one as well on tidal disruptions, and so there's some already in the AGN SC white paper as well.
Perfect.
So what I'll do is I'll tell Bene to get in touch with Subi, and then maybe there's it might be worth just putting in one white paper which sort of cuts across collaborations or something, and they can work on that. But thank you.
That'd be awesome. I think Chad is on for informatics and statistics, right?
Yes. Can you hear me all right?
Mm-hmm.
Okay, so sorry, Fed. My tendency is to have more slides and kind of flip through them quickly. It's probably going to be a little annoying for you. But so I just start off with this title, and then you can go on to the next one. Tom is on the call as well, so he can chime in as he wants. So the ISSC, the Informatics and Statistics Science Collaboration, is very large, and it's part of a growing community of data scientists, as we are tending to call ourselves now, who work in the area of astronomy. Basically, I would characterize them as individuals motivated by advancing the science, but at the same time developing new methods of data analysis. Next slide. Next. And I thought a good way to understand what the ISSC is like and what we're up to is to think about the diversity of people who are involved. So I broke it up into groups. So there are people who are actually primarily active in another science collaboration, but they're definitely interested in these advanced data analysis issues, such as Salman Habib, Fed, and Sam Schmidt at UC Davis, who's obviously very active in PhotOZ problems. They're all members of our collaboration. Next. There are statistics and machine learning experts who are interested in accessing the LSST data and its problems, just because they're interested in the sophisticated problems that we're facing, such as Yan-Chi Chen at the University of Washington. He built a sophisticated method for finding filaments. He built a catalog for SCSS and is planning and hoping to do that for LSST as well. Another good example is Lior Shamir at Michigan Tech, who's worked a lot in machine learning applied to astronomy as well. Next. There are people who are trained as astronomers, but whose expertise is primarily in data analysis, including Tom, who again is on the call, Eric Feigelson, who's long been involved in Astro Statistics. Just this past summer, they added on an astroinformatics week to their very popular summer school. I know Tom was involved with that. I've been involved with the Astro Statistics school for many years. He also was involved with the TDS workshop this past summer. And another example is Peter Freeman here at CMU, who's in our department, but is an astronomer. He's working on developing LSST-based projects for use in data science course, and we're hoping to get engaged with the EPO people on how we could collaborate on that. Next. And then I kind of put myself in a class by myself. No, statistics and machine learning people who really just enjoy being part of the collaborative environment. You know, this is listing some of the things that I do, but I know that there are other people involved in the ISSC who do similar things. I've, been an internal reviewer for desk papers. I've taught in the LSST Data Science Fellowship Program, in addition to collaborating on projects. Next. So what do I view as our ideal role? Well, I like to think of it as there's been a shift from the so-called variance-dominated era in astronomy and cosmology, where samples were small, to now with things, especially with LSST, where we're in a bias-dominated regime, where the problems are with the deficiencies in the models that people are assuming. You can't just make simplified assumptions and hope to get away with it. And so this means the development of new methods, as I was referring to earlier. You can't just take the existing methods that have been applied previously and scale them up to larger data sizes. It's not just a matter of getting more computing power. And I think of it as the gap between the methods that are being developed in statistics and the actual application are getting larger. We have to think more about tailoring these methods to the specific problems. And of course, that requires a greater amount of expertise on both the data science and the astronomy side, and then the collaboration. Next. So, but what are the challenges? Well, definitely, I feel like we face a lot of challenges, and I think in part it's the diversity I was referring to when I went through those lists of different types of people. I feel like there's still not a cohesive focus within the science collaboration as to what sort of things we should be doing. There's a lot of members; they're doing a lot of things to help LSST, but they're not working. We're not working in a coordinated fashion. There's always issues with funding. The data scientists involved, they have a lot of different focus areas. They're working on different problems, so they have a lot of divided attention. I also, when I go to these meetings, I hear problem after problem that I feel as if we have people who could help with. It's a little bit overwhelming. There's just so many data science problems within LSST. And then, of course, the communication issues between the different fields, that can be a challenge. Finally, a little plug here. This is something I've been wanting to do for a long time. I finally did it. I created a Slack channel called Ask the ISSC. I'm hoping to make it into something where people feel comfortable going there and posting maybe even trivial data science statistics questions. Point your students to it if they have questions. And I'm going to take the lead on curating this. In some instances, I might answer the question myself, or maybe find members of the collaboration who can help with answering questions, just as a way of having a greater outreach into the LSST community, maybe hopefully seeding some further collaboration. So I'm going to be publicizing that to a greater extent, but please keep that in mind.
Okay, thanks a lot.
Can we publicize it within our science collaborations?
Yeah, exactly. Yeah, that's what I'm hoping for. I'll be putting something together that you can send out, or if you want to do it yourself. But yeah, that's exactly what I'm hoping for.
That's great.
All right, so unless there's any more questions for Chad, I think it's Milky Way Stars and Local Volume up next.
Okay, that's me, John Gizis. Believe it or not, one of my co-chairs preferred to be at a faculty meeting. So anyway, so probably the main activity recently are of course, the white paper cadence things. Of course, many of those are going on sort of not directly within our collaboration, but in conjunction with others. In particular, a number of our members have been contributing, I think, to the TVS proposals related to the galactic plane and bulge, such as Will Clarkson and so forth. So that's been, I think, a helpful contribution. There's a white paper on observing the LMC-SMC South Celestial Cap region, which is very important to our collaboration, and so that white paper will be going forward. After some discussion, since it's not exactly clear what one should propose with the galactic plane, Jay Strader decided to put in sort of the maximal, quote unquote, no compromise proposal for the galactic plane, which was to do it at the same level as wide, fast, deep. So he is writing that paper with contributions from a large number of people. That's definitely happening. And so where that goes later on, I don't know, but at least it will probably include fallback options as well. And there are a number of different contributions to, wide, fast, deep strategy things going on, but not necessarily from our collaboration as such. I was thinking about doing a twilight paper, but I'm not really sure whether that's worthwhile or not, and probably I guess we could see in some sense, it seems from polls of members that perhaps the most interesting thing is they'd simply like to see the short exposure data for all the filters at some level, but not necessarily, for at least for calibration overlap purposes with Gaia. But whether that really rises to the level of a white paper or not, I'm not sure. I would comment, this is not on the white paper as such, but it may as well go on this slide, as we're increasingly seeing major contributions from the new members, in particular in Italy, which has great interest in the sort of stellar and galactic science, and also the UK. So there were LSST UK funding proposals, although I don't know the status of them, and a number of efforts along those lines, and of course a number of meetings going on there. So for example, from the Girardi group in Italy, was delivered a sort of large sort of star count simulation of the galaxy, which could be of use to many groups. Can we scroll to the next slide? I also appealed to members to tell me, like, did they have any activities that could be advertised or should be reported on? And what I got back from various people actually was their contributions to various conference and meetings that went on. You may have been at the blending workshop at the Tucson LSST meeting, and I'll say something more about some things that happened there later on. The people were at the LSST Cadence Hackathon and are contributing to white papers out of that. I was at the W1st LSST Princeton, but I sort of, but not for the whole meeting, and I sort of perceived as more an extragalactic meeting, so I didn't worry too much about it. The Palermo meeting was very successful in Italy on LSST and has led to some contributions to the white papers. There was contributions to the precision astrometry in the 21st century meeting, where LSST, extends the Gaia results, and so that is being advertised. And Will Clarkson talked that he was at the microlensing 22, and so many of these overlap with TBS activities, who will probably describe it much better later on. Oh yeah, I can't scroll down. Scroll. Sorry, go ahead, Ben.
You've got about a minute left, John.
The key issues, I keep hitting the button, right? I'm like, nothing's happening. Probably the key issue, of course, that is ongoing continues to be the issue of the crowded field photometry testing and going on. There was an effort this year with people using real DECCAM data, and sort of the UCLA group, Mike Rich, a graduate student named Veronica Dyke came and presented those results in the Tucson meeting and did a really wonderful job of it. And so at the moment, the LSST as it exists now without any special tuning really does not perform as well for the sort of faint, crowded sources as one would like with the sort of specialized sort of DAO-like curves. My impression was that that's partially just due to perhaps it needs some more iterations of subtracting the stars and detecting things, that really some of the issues just related to detecting things, but in any case, that's an ongoing effort. Of course, we understand that LSST is considering Scarlet, and ideally there would be a single galaxy and star deblender. It would be a very unfortunate situation to have, like different pipelines for different parts of the sky and so forth. So we really would like to get a single solution. So there's an effort going on, in particular in collaboration with TVS, and Federica Collins Slater at DM is leading it, since of course he's on the inside. And we're going to work on testing Scarlet and seeing to what extent we can tune the parameters and the star detection to basically perform well in crowded fields. So that work is ongoing, and I think it's going to be productive. Of course, in terms of astrometry directly, probably the biggest contribution is that, or is that Gaia has finally come out, so we know that Gaia works. We know that we're going to get these great positions. So that is checked off of the sort of the roadmap and the requirements, and of course that's sort of keeping people busy right now. In terms of, now is the time, if you're interested in this sort of science, to be writing papers based on the Gaia data release and not dreaming about 3 or 4 years from now. So things will settle down, I think, a little bit. I haven't heard of any new developments on star-galaxy separation. People got satisfied with some of the things that were happening a few years ago, and so I don't have any new results to point out on that front. But all in all, we're a little disorganized. We don't have any publication policy. We don't have a code of conduct. I think these are a lot of things are clear that we can be working on next year.
Get away without telling us a bad thing. You can get away without telling us about the bad thing because we are short on time. So
exactly.
We won't pressure you on that.
Please go ahead.
I recommend that we push questions to online and other means. We're already at the top of the hour, but we do have 2 more science collaboration, and Aparajita is joining us despite being on leave. So thank you, Aparajita. Are you still there?
Yeah, I'm still here. So just going back to the slide before, so I just wanted to mention the Strong Lensing Science Collaboration work very closely with the DES Strong Lensing Working Group. We try and pull together all the different aspects of strong lensing science, and just acknowledging the co-chairs there, Danny Goldstein and Tom Collett, as well as the background work that Phil and Chris Fastnack have put into strong lensing. So if you could go to the next slide. So just to be very quick, so I think the biggest thing with strong lensing is LSST is really going to revolutionize the field, particularly in the sense that we're really going from handfuls of objects to proper statistical analyses. And, the numbers are kind of there. I won't go through them all, but we're basically going from 1,000 known sources up to, tens of thousands of sources. And this is going to really change the way that we use strong lenses. And obviously there are lots of different aspects to strong lensing science. And we overlap strongly, as I mentioned before, with DESC, particularly in the time variable strong lenses. We also have strong overlaps with doing galaxy science, and also the transients group, the AGN group, and also the DESC-related dark matter task force. If you could go to the next slide. So our main focuses at the moment are doing strong lens discovery, so really setting up the LSST strong lensing discovery framework. There's a number of ways you can do this through automated algorithms that basically look for color differences in the images. There's a lot of groups working on sophisticated machine learning, and essentially the problem there in all these methods is that your false positive rate is about 10 times or more your true positive rate with all of these automated processes. And so there's always a strong element of human inspection or visual inspection. And actually Phil and I and Anna-Prita Moore have worked quite closely with citizen scientists and have really looking forward to LSST, looking at the kind of best way to combine both the machine learning aspects of lens finding together with the citizens to build a really efficient machine. And other things we're looking at, oh, thank you. I forgot what was on the slide before, but yeah, I think we're also looking at deblending and essentially
sorry, I didn't realize.
Kind of, that's all right. You can kind of think of like strong lenses as kind of mini crowded fields. A bit like what John was just discussing, but in this sense, you could find kind of serendipitously, you could imagine you can find strong lenses through kind of those things that Scarlett, for example, find as undetected sources or unknown sources. So there's some work that I'm trying to start up with Peter and Fred in looking into that. And Phil and his student are looking at doing catalogue searches for strong lenses. And there's also lots of work going on with DC2 in terms of inputting strong lenses into that. Yeah, next slide. What's really quite important also for kind of lens discovery or refining our samples is really modeling all these systems, which traditionally have taken, of order weeks per system. And we obviously can't afford to do that when we're in, the realm of tens of thousands. So James Nightingale has been working on a really nice package where he has a kind of fast automated modeling system that will allow us to look for do the kind of 99% of well behaved strong lenses and get models out extremely quickly. And it's a really neat package, and obviously then, focus our hand or manual efforts on those that are more complex. So that's work that's in hand, and we're testing that at the moment with a bunch of different kinds of known lenses that we know today, and also hoping to put in some SIMs. Next slide, please. So the other issue is the white papers. So there's some strong lensing input into observing strategy, and from the point of kind of what we call static lenses, so those that aren't variable, I think essentially because they're so rare, it's basically wide area, but also we want really good image quality, and that's kind of shown in this plot that you see there on the right. So you can see that most lenses are actually really compact. And so there is a requirement in terms of successfully finding lenses by looking at good seeing data in the blue wavelengths. And that's kind of the focus of the static strong lensing. On the variable side, thanks. Yeah, next slide. The strongest constraints from Fed, you could go to the next slide, please.
There's a bit of delay.
Yeah, sorry. So basically, the strongest constraints in the observing strategy actually comes from the time delay science that you can do with variable quasars and supernovae. And there's been a lot of work by Sherry Suyu and her student Simon Huber, as well as Phil and Timo and various people in the desk strong lensing working group in looking at what the best observing strategy will be, or how it affects the precision that you can extract. And it looks for kind of strongly lensed supernovae that you're looking at the kind of alt-sked rolling situation to get within 4%. But yet for the quasars, it seems that the precision is comparable between the rolling and the baseline observing strategy. And that all feeds into the desk white papers that Eric mentioned earlier. Next slide, please. And then just to finish off, I've just summarized kind of what we're planning to focus on in the near term. We're working on a roadmap that complements both the desk roadmap as well as the galaxies, and then a bunch of other things, including DC2 and really looking at the white papers and our follow-up strategy, and also working with the dark matter white papers that are being written at the moment. And I'll just leave it there.
Perfect. Last one. Rachel, you want to take it away?
I would, but I'm currently taking notes, and I don't think I can do both.
Oh,
so do
okay.
you want to do this, and I will take notes to make sure they're complete?
Sure, I can do that, and that will actually make it easier to flip through the slides.
Right.
So we had a number of activities in TVS this year. I'm going to rush a little bit through them. We have structured ourselves so that we now have task forces that tackle particularly time pressing problems. So we created our first task forces to address the deep drilling fields and the mini survey proposal planning, when we thought that the call was going to be only for deep drilling field and mini surveys. That extended to sort of coordinating the white papers for the white fast deep as well. We have a specific task force on stellar variability that produced some of the analysis that was talked about before, mostly at this stage led by the Italian team that has analyzed DECAM images to understand how the photometric performance in credit field photometry, and this will extend into a collaboration with the Galaxy Science Collaboration to try and apply Scarlet on the same images to compare it with more traditional crowded field photometry tools. We had a broker requirements task force that was led actually by Rachel, who created a very useful document, I think, that was considered useful by all of the alert the people involved in alert broker preparation and creation, that surveyed the community to understand what their needs were in terms of products and means of distribution for an alert broker system, as well as a survey among the brokers, the broker creators, to understand what their challenges are and what input they need from the community. And we also have a task force that is moving a little bit slower on understanding whether the variable the LSST will deliver from the level 1 and level 2 data products, as to call them with an obsolete name, are sufficient for us to characterize variability on variable and transient sources that are of interest. We're creating a roadmap. We're not moving super fast on this, but we now have an outline on the roadmap and designated editors for each of the chapters. As I always mention, transient and variable stars collaboration, transient and variable star phenomena are a very large set of astronomy, and they're a very diverse set of astronomy, both phenomenologically and physically. So the complex outline of our roadmap, which you see here as a tree representation on the right, reflects that, but we have a number of people who designated themselves to write different pieces of it. We had a number of meetings this year, beginning with the LSST Transient Variable Star workshop, which was enabled by the Enabling Science proposals of LSST. That's in the center. It was in June at Lehigh. I'm very proud of the fact that we had a very diverse audience for this meeting. We had almost 50% gender balance, and we had a majority of junior people over more senior people, which is something that is quite important. We also enabled remote participation as much as we could, because we're now a rather diverse, rather centrally dislocated science collaboration, as I'll show in a second. We also had two meetings in Italy, one that was in fact a transient and variable star workshop in Naples in April, and one that wasn't a specifically transient and variable stars collaboration workshop, but also involved a lot of people from the Galaxy, the Stars Milky Way and local volume science collaborations in particular. There is obviously a lot of overlap there, and the large number of Italians that have joined TVS and have joined the data rights holders with 15 PI ships have interests that sort of straddle these two science collaborations primarily. And we had a good participation in the hackathon, the LSST Cadence hackathon at the Flatiron Institute in September. This hackathon was organized to get science collaborations together, and we had we were able to achieve representation of almost all the science collaborations, with some overrepresentation of DESC and TVS, also reflecting the larger size of the collaborations altogether. In terms of white papers, we are writing a number of white papers, again, reflecting both the size of the collaboration and the diverse science scope of the collaboration. We have in the pipeline, to some degrees of readiness and with some probability of actually being delivered that may vary, about 9 papers that will propose for wide, fast, deep cadences, 8 mini-surveys, 6 deep drilling fields, and a target of opportunity paper for follow-up of gravitational waves, which is led by TVS and also involved DESC participation. Rachel and I have been working on this for some time as science collaboration chairs. We put together a code of conduct and a charter that defines the structure of the science collaboration. We have asked all of our science members to sign by the charter and the code of conduct, and we're in the process of finalizing the publication policy, which we found being a little bit harder and more contentious than the code of conduct and charter, as one may imagine. So right now we have finalized the first 2. We're still collecting comments on the publication policy. You can read our Transient and Variable Stars Collaboration Code of Conduct, as well as our charter, which has now an organizational map, which was inspired by Eric's comment on DESC being the most organized science collaboration. So a little bit of competition sprang the creation of this Transients and variables task collaboration sort of hierarchy and power flow chart and map of, I don't know, how we organize ourselves. Some of these things are still in the making. There are a few boards that are mentioned here, like an ethic board that will review violations of the code of conduct and a publication policy board. These positions have not been filled yet, but the charter has been approved by most of our members. Again, we're still accepting comments on the publication policy to fine-tune it. I'm going to go back a couple of slides to show that we have downsized our science collaboration as a consequence of the distribution of code of conduct and charter, not so much because the code of conduct and charter were contentious, but because we took this as an opportunity to actually see who is still tuned in into the science collaboration, at least enough to respond to a call for signing the code of conduct and charter. So we currently have 196, which I think grew to 199, with a few more people signing the code of conduct last night, members from 269. We are removing the remaining members from our channels of communication, and we will continue to ping them and ask them if they want to join the science collaboration again by signing the code of conduct and the charter. Lastly, we became a rather geographically distributed science collaboration. Here are maps of our participants. The size of the dot represents the size of TVS at a given institute, but also there are multiple institutes that are located in the same geographical area, so you see that points sometimes overlap. So we obviously have a large number of members in Seattle. We have a very large number of members on the East Coast, and we have a lot of members now in Europe, particularly UK and Italy. And I can just zoom in into these charts, but yes. And the European collaboration remains a little bit diverse, with participations not only from the UK and Italy, but also France, Slovenia, to name a few. And I think that's it. So I'm going to close the meeting myself, 15 minutes late.
Thank you to all. That's very, very impressive.
Yes, thanks, everyone.
Thank you.
Thanks.
For impressed.
Bye.
Ask questions and can contact us to ask them and give us feedback.
It's only the work of 800 people. I don't see why it took more than an hour. Okay, very good. Bye-bye.
Thanks, everybody.
Bye-bye.
Thanks a lot, Ed.